Hello everyone, welcome to CSC Core Concepts for learning UML diagrams. Now in this video, I am going to discuss about how to draw an activity diagram. So let us first understand what does an activity diagram does. It shows the steps involved, how the system works. Okay, so it will help us to understand the flow of control and in a way, in an order, in a proper order in which the activities happen. Now the activities can happen in a sequential order, that is one after the other, or sometimes we observe that certain activities work in concurrent, that is same time they are occurring, multiple activities are occurring at the same time. So this diagram also explains us with the help of it that how one action can trigger another event in the system. So it starts from an initial point and ends at a final point, and in between it shows the different decision paths along the way. So majorly they are used in business and process modeling to show how the system behaves over time. So let us understand the notations used in the activity diagram. So the first notation is the initial state. So it discusses the starting state before an activity takes place. So a process can have only one initial state, okay, unless you have a nested activity. So a dark black filled circle is used to represent an initial state. So let us say if I represent like this, so it shows that the first state here is the initial state. After that, we are opening an application. The second major notation is the action or the activity state. Okay, so it represents the execution of an action of an object or by objects. So it is represented using a rectangle, but you can observe here that the rectangle is not a squared rectangle, it has rounded corners. Sharp corners are not there. So any action or event that takes place is represented using an activity. So you can see here this diagram represents that initial state, and then the application is opened. Then comes our action flow or control flow, how one flow from one object to another. So it shows they are also referred as paths or edges, and they are used to show the transition from one activity state to another. So you can have multiple incoming paths. Okay, so multiple paths follow to one state, that is also possible, and you can have multiple outgoing also. So from one activity you are going to multiple activities. So a simple line with the arrowhead depicts the control flow. So you can see here that there are two activities, changing a wallpaper and generating a playlist, and both merge to a different state. Okay, so this there are two outgoing actions of this we can see. Similarly, we have the decision node and the branching. So whenever you want to take any decision or decide the flow of control, we can use the decision node. So the outgoing arrows are labeled and the conditions with guard or expression. So we are going to write the conditions or the expressions on the as a guard. So what is a guard? Guard is basically which you write on the arrow. So suppose we apply this is the condition. So let's say we have an example. We have a condition on we are inputting some number, right? So if the number is odd, then we have to display the number, and if the number is even, we have to display an error, right? So if I want to show it using an activity diagram, so you can see here that you will have one. This is the activity, that is input number. This is the link. Now this is a guard. Okay, so the condition is written over here. So if yes, okay, so you display the number. If it is no, you show the error. So anything which you write on this is the guard. Then you have this guard again. Yes, we have. So this is the guard you can see here, as I discussed in my earlier slide. So it is the statement which is written next to the decision node. So whatever decision node is there, whenever you write, so you can write it within the square brackets. Okay. So this is the state, initial state. You have a decision, and based on the decision, your condition is true. Either your condition is false. So if your condition is true, you go for action 0. If your condition is false, you go for action 1. So this condition is written inside the square brackets. Okay. So this is how you can represent the condition using guards. Then a major symbol is the fork symbol. So they are used to support the concurrent activities. Let's say this is here there is one activity. From this activity, from two activities are produced. Okay. So this symbol is called as concurrent activities. You can have more than two activities also. So both the activities will get concurrently, executed concurrently. So there is no decision. Okay. Like if I want to do something and two activities are reproducing from there. It is not a decision node. So you can show it using a solid rectangle. See, it is not simply a line. It is a rectangular bar which is filled. Okay. So one arrow and the number of arrows you have the activities here. So in this example, the activity of, let's say one example, you have making coffee. So if you want to make coffee, it has two, no, it goes two activities, that is adding the coffee and steaming of milk. Okay. So two activities you can do the parallelly. So while steaming the milk, you can add the coffee. There is nothing called as decision to be taken here. And you can see this bar is a solid rectangular bar. Then you have the join nodes. They are used to support the concurrent activities. Okay, so when concurrent activities, they merge into one common activity or a decision, that is a join. Okay, so for join we have two or more incoming edges. See, so here it is a fork symbol, making coffee. So adding coffee and steaming milk, and finally your coffee is done. So it is merging to a final state. Understood? So both of them are done. Merge event. So scenarios arise where there are not been executed concurrently, have to be merged. See, this is a concurrently they are doing and you are merging. And this is what when you have to merge. So whatever it is happening, you are merging into a decision, right? So we cannot have, it is not concurrent. If the activities are not concurrent, but they are different activities which result into something, that is a merge. Let's say for example, this is the initial state. Then you have a decision whether the number is even or odd. This decision is using a guard. Okay. So yes, if the number is odd, you have lot of things to be done. That is, you add 5 to the number, then you multiply by 5 and you display the number, right? And if the number is even, then you have to add 7 to the number, multiply by 7 and display the number. Now finally, whatever is that, you come and add to the number. See, these two were not concurrent activities. If they were concurrent activities, then we would say it is join. But this is a merge. Okay, the type of activities which they are doing is not concurrent. Either they will go for yes, either you will go for no. You are not going to do both the activities together. Concurrent means when you are doing both the activities together, right? So here either you are following this path or you are following this path. So whatever path you are following, finally whatever is the result, you are adding 20 to the number. So it is a merge relationship. Then you have certain group related activities called as swim lanes. So swim lanes are basically, sometimes what happens, we have one activities which comprises of multiple activities. Okay, it is a set of multiple activities. So in that case, we can group the related activities in either column wise or you can write row wise. So if you are writing column wise, it is going to be vertical. If you are writing row wise, it is going to be horizontal. So it shows the modules in the activity. So they are called as swim lanes. Now swim lanes are something which is not mandatory to show in an activity diagram. If you wish to show the breaking of the activities inside one swim lane, you can show. Otherwise, you can not show. You can show each of them as an individual activity. So let us see the same activities here. We had list of activities, right? See, if the number is odd, we perform so many activities. So many activities, you can write them in a box. Okay, you can put them in a box. Okay, so this is one swim lane. This is the second swim lane. And on the top of this, you have to write the activity pattern 1 or whatever is the name. Understood? So here also you are going to write activity pattern 2. So you are breaking down into, you are showing them as swim lanes. Then comes the time event. So what is the time event? It shows the time taking processes. Okay, hourglass type of a symbol. This is an hourglass type of a symbol which is showing that this process requires certain time to complete. Let's say, for example, if you have a form processing in passport or any other such application, where they give you certain instructions that your photo should be of this, not exceeding this size, or it should be of a JPEG format. So whenever you upload any image, okay, they will do some processing to check if these conditions are met or not. So that is a time taking process, right? So for that you are having this symbol. So when you input any image, okay, so you wait for some time and then you process it. Then comes the final state. So final state is represented by a dark circle and outer layer of hollow circle, right? So it is a filled circle with a this. So system can have multiple final states. Okay, you can show, because one decision can show one final state, one can show another final state. So you can have. Okay. So how to draw an activity diagram? So first you have to identify what is the initial state and the final state. What are the activities? So in these activities, whether there are certain conditions, constraints, merging, concurrency, or you have multiple activities grouped, and based on that you have to draw the diagram. So let us see one example here. So of releasing a work order, like see, it is the initial state. You don't need to mention the word initial state. The symbol itself represents the initial state. Then you have the release order work, let's say. Then you are taking a decision whether you are release the order work. You will release only if the materials are ready. So if yes, then you are going to assign a task. If no, you are going to reschedule the work order, and both they come and merge. Whatever is that, you have to generate the next order, right? And this is the final state. Similarly, you can have activities with swim lanes. So this is an activity diagram for an ATM machine. So you have three entities here: customer, ATM and bank, right? So they are interacting. So this is the initial state where the customer inserts the ATM card. So it goes to ATM machine, validates the card, and it returns to the customer, where he enters the PIN and the bank has to authorize the PIN. So either the PIN is authorized or not. So if it is yes, okay, you are going to enter the amount, right? And if it is a no, then you are going to uh, come out, eject the card. Understood? So this is the arrow. Now, after entering the amount, you have to check. The bank will check whether the balance is sufficient or not for the amount to be withdrawn. So again, this is a card in which you're writing the condition. So if it is yes, then you are going to debit the account, okay, and otherwise no. If it is no, sufficient balance is not there, then you are going to display the balance and eject the card. So if it is a yes, then you have two activities to be done. Okay, so here it is a fork. You can see this bar is there. This is a fork. So one activity is that you will get the cash, and second is that your account will be debited. Okay, the amount will be debited. So after getting the cash, you are merging over here. Okay, and you are going to display the balance. So this is a merge point, you can say, for two conditions. One is that if your account gets debited, and second is that if you have insufficient balance. Similarly, this eject card is a merging point for which activities: if your balance was sufficient, you displayed the balance and you eject the card. And second is, if the pin is wrong, then also you are coming and connecting over here. So after ejecting the card, you are going to give the ATM card back, and this is the final state. Okay, so I hope you understood. These are the swim lanes, because these rectangular boxes, you are showing multiple activities for the customer, for the ATM machine and for the bank. Then comes the example of a order processing. This is shown in a horizontal way. Okay, here we were showing the forks in the vertical direction. So you have the request, you receive a order. Okay, receive a order. So either your order gets accepted or the order gets rejected. So if your order gets accepted, you fill the order. Now you have multiple activities going on concurrently. One is that you are busy shipping the order. Second, you are generating the invoice, both at the same time. So you generate the invoice, accept the payment, and you come here. Shipping order, you come here. Understood? So this is a join event, right? And whatever you are doing after that, you are coming here merge event, that is close the order. So if your order is rejected, anyway you are going to close the order, and this is the final state. I hope you understood. So this is the requested order. Order is going to receive, and from receive either it is a decision node, and this is written using the guard. Okay, that order is accepted. If yes, fill the order. Send invoice, this is a fork. Okay, where multiple activities are being taken, are taking place, right? And this is how you are processing the order. So I hope you understood how to draw an activity diagram. You can go through more examples like this, and you can try drawing the activity diagrams on your own. So don't forget to like, share and subscribe to CSE Core Concepts for more such informative videos. Thank you.